Let's take a look at how we can use the difference of two square method to factor a binomial that's a little more complicated than just some of the basic ones we factored. Now the same rule is going to apply. I'm going to look for perfect squares, that's numbers you can take a square root of, and I'm going to have two sets of parentheses where the only difference is one has a plus and one has a minus sign in it. So here's I think we can all agree this is fairly more complicated than what we've looked at recently. And before I start anything, I'm noticing right away I can't do square roots right away. 2 and 200 are not perfect squares, but I can take a look at, like we'd always look for, a greatest common factor before I go any further with this. So looking at 2 and 200, I can see I can get a 2 out of both of those. Also, I see they both have an a in common, so let's get that 2a taken out of both of these. And then hopefully what's left over, I can now try difference of two squares with. So I'll have the 2a as my greatest common factor. I'd be left with x to the fourth, y to the fourth, minus 100 z squared. And taking a look, oops, that's a 2. Taking a look, I can see that, yes, difference of two squares will work now. Each of these, or I guess the only number I really see there is that 100. It's a perfect square. Also, you need to make sure you have even exponents. As long as your exponents are even, you can take a square root of them. Really, you're just dividing by 2 with those exponents. So the way this will factor then into difference of two squares, I like to do those little marks to kind of show what I'm splitting this into. If I take the square root of x to the fourth, y to the fourth, like I said, it's kind of like that, dividing that exponent by 2. So I'd be left with x squared, y squared. And then if I take the square root of 100z squared, I'd be left with 10z. And you'll have two sets of parentheses. They're going to be identical to each other, with the only difference being one will have a plus sign and one will have a minus sign. So I'm going to factor this down into x squared y squared plus 10z and x squared y squared minus 10z. Don't forget to bring down your GCF along with that, so that 2a will be in front. This time, this actually is my final answer, factored with difference of two squares, but it's always worth looking for, seeing if you can factor anything again. Oftentimes, these problems have another difference of two squares embedded in them. We'd want to check a couple things. This one's done, by the way, so if you're done with the video, feel free to stop. But if you want some bonus information, here we go. So what you want to check for is, first of all, if you have a sum, which you will, that sum side cannot be factored again because it's called the difference of two squares. So whatever parentheses has the plus sign in it, that one is probably most likely done. However, this one that has a subtraction sign, since that's a difference, you may be able to factor a second time with difference of two squares. This part, we could do the square root of it. That would become xy. However, I cannot do the square root of 10. I'd get a decimal, so that's why I cannot factor this one a second time. However, I'm pretty sure we're going to take a look at least one in class where you can factor a second time with difference of two squares. But this one's done. If you watch the bonus information right here, congrats.